Greetings. Welcome to our 50th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois and technical director of the FGI. On today's podcast, we are going to focus on our January 16th webinar titled Electrical Leak Location, ELL, Planning and Preparation. I'd like to quickly reintroduce our speaker, which is Andrew Colby. He oversees the electrical leak location and construction quality control departments at BLE. He recently took over the role as branch manager and business manager for the BLE Columbia, South Carolina office, and he has over 20 years of experience and expertise conducting electrical leak location surveys. So, Andrew, thanks so much for joining us again and giving an excellent webinar on Tuesday, January 16th.
Yeah, thank you, Tim. I appreciate the opportunity to present, and welcome any questions, and open to the talk, and as much education and background from my experience that I can give to folks. I would be glad to do it.
Great. Because there was great interest in your presentation, we have 26 questions to go through today on this podcast, and these questions came from or during your webinar and in the subsequent follow-up survey to your webinar. So, and it was also well attended with almost 300 people attending the webinar. And so it's generated quite a bit of interest and questions. So here we go. First set of questions are from the live webinar that we didn't have a chance to answer during the webinar. So question number one, how do you handle wrinkles in the geomembrane while conducting electrical leak location? And do you have a preferred wrinkle size? In other words, is there a size of wrinkle, for example, 4 inches? Some states allow 4 inches. Do you want it more or less than 4 inches?
Yeah. So Tim, I know we're interactive here with the slide presentation from the 16th. Could you go to slide number 11 and kind of demonstrate what we're looking for? You can see some wrinkles ahead of us. So here we are in live action performing the survey. So typically on the exposed methods, you want it to be reasonably flat, and have intimate contact between the soil subgrade or the subgrade surface that the geomembrane is it's installed upon. But the great advantage is on the exposed methods, you can literally step on the wrinkle and flatten it out in order to get a successful survey. The covered wrinkles require really tight and stringent CQA and third-party monitoring during the protective cover installation, because once a wrinkle's there, it's there. It's never going away. And you've got to do a really good job of making sure you keep that liner as flat as possible and have intimate contact with your subgrade. The industry standard, and most practitioners I talk to when we talk in groups and kick things off of each other, 4 inches is what we typically see as a maximum. I think some materials you can get away with 4 inches. Some materials you don't want it that thick. A lot of these things are site specific in what you're dealing with, but no more than 4 inches is a maximum. And I would say less than that. What I would encourage, we would like to see intimate contact as much as possible.
Right.
One more point, Tim, I want to make. When you do these surveys specifically on the exposed methods, you don't want to do them in the heat of the day. I'm located in the southeastern part of the United States. When it's 95 degrees in the middle of the afternoon, it's not a good time to be doing these surveys. You want to do them in the morning or do them sometimes at night under light plants when everything's nice and flat and it's not wrinkled and everything's laying nice and taut.
Right. Early in the answer, you mentioned stepping on the wrinkle and trying to push it out. But if it's big enough and it folds over, I mean,
Yes.
That's going to act as an insulator. And if there was a hole in the top of the wrinkle, you wouldn't see it, right?
That is correct. And with the arc testing method, I'll say this, you can get away with a little bit more because you've got that arc and it'll go into that hole, and maybe we'll make contact if you've got good conductivity underneath, if you've got a wet soil subgrade underneath it. But other methods, you're exactly right. And that's why I stressed during the covered side of it, once you pinch that wrinkle off, if there's a hole there, you're never going to get back to it. It's covered up. And it's a flow. I mean, it's an instant flow of a path to allow unpleasant things through your liner system.
Right. Okay. Thank you, Andrew. Question number 2. Either in the covered or exposed application, do you set up grid lines so you know where you've been and where you're going to go?
We do. So again, we'll reference slide 17. So you can see when we're doing the arc testing method, we were on slide 17. I'm sorry, slide 11. I'm sorry, Tim. Go back. I had it marked here. I was looking at 17. So this slide right here, you can see that our arc tester is 36 inches wide. And you can see that those seams, each panel welded together on a typical HDPE or on a system like this, we know what the widths are. They're typically anywhere between 15 feet and 22 feet once they're welded together. So you've got a pretty good pattern on how many passes you have to make. A lot of times when you come to these sites, there's some light dust or something, so you can physically see where you've been and where you haven't been. But the lines on the seams give you a really, really good indicator of kind of keeping your path and overlap. And I like to see an overlap of passes at least an inch. We try to go 2 to 3 inches and make sure we cover all the surface area. When you get into the exposed methods are pretty easy. When you get into the covered methods, you know, if you're on a sand or you're on an aggregate, you can literally see your foot traffic and where you've been. But we have laid out string lines before. We've laid out traffic cones, and basically whatever your grid system is if it's 5 by 5 or 10 by 10 or 3 by 3, you just space those out as you go and you shoot for them and walk them. The great thing is with the mapping system, we'll get into that, I think, on the next, on a few of these, I think, on some questions I saw previously. You can also see on the GPS system, Tim, on the mapping side where you've been, and if there's something maybe that you got a little bit out or didn't see, even if you did have it gridded out, you want to make sure that you get everything, correct?
Great. Okay. And the wand or the spark tester that's being dragged on the geomembrane now, you said that's 3 feet wide?
Yes, this instrument like in front of us is 36 inches. Yeah. I've seen water puddle about the same, 36 inches to 48 inches wide is the surface area you're covering at one time. Yes.
Okay. Okay. Thank you, Andrew. Question number 3 from the live webinar. On the arc test photo, there's a nice big puddle of water ahead. Is the technician going around it or straight through it with the 35 kilovolts?
Great question. That's a funny one. Go to slide 6 so we can look at it together and talk about it. So you can see that the liner system to the right, this was a large cell. So we actually arc tested this in pieces. So they would get 2 or 3 acres down. We'd come in and arc test it. It was a double line system. They would go back and on rain days, lay composite down to keep construction moving, keep things going. So you can see where he's at. He's on clean liner. The liner over to the right with the puddle actually is stuff we had tested previously. So obviously he's not going to go through that puddle, but I do want to note a couple things on this. You know, water's highly conductive, and there's a reason why we call this presentation planning and preparation. There's a reason why that slide is in there. I wanted people to be able to see things like that, hey, if we have to survey that, there needs to be somebody to plan and prep and get that out of the way. The easy way around it is while we're in action surveying, if it's there, you know, we find the site personnel and say, hey, we'll survey everything. Please have that ready for us. We'll survey around it. We'll come back and catch that at the end to make sure we cover everything. Typical push broom or a leaf blower, just something to move that ponded water after we've surveyed around the area so we can come back and get that so we make sure we get everything. But good question.
Yeah, good. Okay, next question. About the dipole mapping, wouldn't it be better to monitor values in real time as well and pause the survey to expose leaks to get better signals as the survey goes and leaks are isolated?
Yeah. So let's go to slide 17 on this one.
Okay, let me get there.
So another good question, and we've had some talks among some of us internally that provide this service about the effectiveness. If you find a large hole during your survey, does it mean that everything else was bad and you need to go back and resurvey? So let's run this down. So ASTM 7007 never required mapping. So we were actually looking at everything in real time. So when I first started doing this, we were doing mapping, but we were still keeping real-time values. So unless you've actually performed the test to kind of understand it, when you turn the electrical current on a covered system and you do your artificial leak test or your leak testing per ASTM and get your setup complete, you know if the test is going to be effective or not immediately, knowing that if you have good isolation, if you're holding current flow within the system in order to see the leaks that are established from the calibration to perform the test. So we mentioned in the presentation that larger holes tend to pull current flow out quicker, right? So those larger holes, for instance, if you're looking at this slide right now, as you're walking toward the larger hole, it is going to light up from maybe 60 feet away. You're going to start seeing it. The closer you get, the bigger it gets, the bigger, the bigger.
Right.
The thing is when you have these minute little places, every now and then it'll pop up. Those are the anomalies you mark. It's giving a leak path indicator, but it doesn't necessarily mean it's a leak. So to answer your question is yes, we are looking at everything in real time. The mapping system was added into the most recent covered method ASTM is a requirement really for reporting and display, so that the client knew that, hey, this is what we saw. It wasn't just, we told you, here's what we got. So, that's where we've talked a little bit about, there's some give and take with the mapping. If you know what you're looking at, it's a great thing. If you don't understand kind of how the testing's performed, it is somewhat confusing and complicated and requires an explanation. So we always perform these tests in real time. The mapping and some of these other things are just supplemental to what we're seeing.
Okay. Next question. With proper setup, is there a tolerance level difference between finding a breach or hole between the exposed versus the covered methods?
Okay, proper setup. So yes, yeah, there is. So, the exposed methods, if you look at ASTM, they are used primarily to find the smaller holes. ASTM tells us to calibrate on a leak path. The size is down to 1 millimeter. So when I talked about our calibration, we use a needle to puncture a sacrificial piece of material to calibrate on. So yeah, so when you're looking at the exposed methods, absolutely, you're setting up to find the thing you really can't even see with the naked eye. The covered methods, particularly in 7007 on the ASTM, you're calibrating on a 1/4 inch size hole. So the difference between 1 millimeter and a 1/4 is pretty substantial, particularly when you think about expansion and contraction on geomembrane systems over time, and how large a 1 millimeter hole can become over time. So the covered methods have always been primarily, they're great methods, they're accurate, but you're not necessarily going to see the whole picture. That's why I always say, if you're looking for a leak-free, you really got to think about going both ways. Exposed to get your manufacturer damage, your installer damage, any kind of damage from the construction side, why it's exposed, you pick it up. Then the covered method is that final test to make sure that if there was any larger damage afterwards, hopefully you pick it up and are able to locate it and find it.
Right. Okay. Next question. Do you find any difference in testing accuracy between a thicker HDPE geomembrane versus a thinner flexible geomembrane, such as a 30 mil LLDPE or 45 mil reinforced polyethylene geomembrane?
Oh, good question, because we've tested. We've been through a lot of different liner systems. So to answer your question, the thinner the material, the more potential you have for leaks. I mean, it's just natural, right? So the thinner material requires less voltage to test because your insulative barrier is thinner. Also, on the reinforced liner systems, you've got the reinforcing nylon netting in there. I can just tell you this, leak detection doesn't work unless it's got a continuous side. So if it's just a blown nylon netting on one side and on the other, you've got too much of that near the surface and you're going to get a lot of false positives. So when the material is made and extruded, it needs to have at least one continuous flat side. So not a whole lot of different accuracy as far as the technology and the way the equipment works. It just really depends on the setup, the calibration, and then as long as you've got a continuous backing. I have worked with materials where they are just too thin to leak locate. So when you start getting down below 20 mil, you start getting down below 15 mil, then it's a little bit, it's kind of a trial and error thing to even see if you can do it. We deal with some EPDMs on roofing systems, and some of them we can survey and some of them we can't. If they're deteriorated and are in pretty rough condition, then a lot of times the whole entire thing looks like a leak because you just can't turn down enough current flow in order to get the test to be accurate.
Yeah. Okay. Do you have any experience surveying bituminous geomembranes, and are there any special considerations for this type of geomembrane?
So I don't think we've done some built-up roofs that had some stuff similar, but I don't personally with geomembranes any bituminous material. But I will say this, it's far more conductive, right? Because you're dealing with an asphalt type material. You got sand, you got aggregate. There are limitations to the effectiveness and the accuracy depending on what the material is, but I know folks who have done it. Other colleagues I've talked to, they've successfully been able to perform specifically arc testing and some of the exposed methods on that material. But again, it's one of those things, it's trial and error. I never say never when it comes to this, because I still think as long as this is leak location technology has been around, there's still some things that we just don't know, and we're still doing. Tim can attest to this. It's kind of like research and development as we go. We're looking for better ways and efficient ways to be able to solve problems and look at these materials. So to answer your question is yes and no. I know it's been done. I personally have not performed those tests on that material.
Okay, great. Next question from the during webinar questions. In winter conditions, when holes can be filled with ice, is there an effective electrical leak detection method?
So with the exposed method, particularly the arc testing and the spark testing, there's really not an issue because you're putting direct electrical current onto the insulated barrier. So as long as the material itself is clean and reasonably clean and dry, if you've got an area, most holes in the system, they draw moisture to, on the back side of the liner anyway. So you may have a spot. It definitely has an effect on the covered method. And the reason I say that is because you cannot get current flow to be accurate and precise in a frozen earthen covered system. So if you've got a sand that's that's got a lot of liquid in it and it's frozen, you try to inject current flow into it, it doesn't consistently go across everything. It doesn't move in these frozen type of conditions. So the covered method, it's just not accurate and it's not effective. You want to do it during a thaw. The exposed side with the arc testing, I know it'll work. I've done it. I don't always recommend it because it's cold outside, but but we can do it in that effect. When you're looking at the exposed liquid methods, the water methods, obviously not because of the freeze. But again, it's another one of these things. It's kind of the planning, the preparation, and setting up. So hopefully you don't run into that.
Okay. All right. Next question. For the copper wire to create ground below a secondary geomembrane, is one line or one copper wire sufficient? Is it dependent on the coverage area?
So Tim, in this case, when they say secondary geomembrane, I'm assuming, so typically when I look at this, the secondary's here and the primary's on top. So I'm assuming that you've got something you want more conductivity or access to the subgrade that your main liner's laying on. And as long as you have a consistent subgrade and there's no breaks or anything, and all you need is access to get underneath there, depending on how large of an area you have, yes, I think one line will work. I always say better safe than sorry. So once you cover it up and put it down, having multiple access points just to be safe, particularly during construction, if something gets pulled out or moved or not where you wanted it. I mean, we're all human, it happens. It's always good to maybe have a backup or another plan. So one line's sufficient. It really depends on your setup. And that's kind of where folks like me with experience, ahead of time, it's good to ask those questions, and I can assist with planning and helping set that up to prepare.
Okay. Let's see. Next question from during the webinar. Ohio Environmental Protection Agency requires electrical leak location at landfills covered ELL on top of drainage layers and exposed at tie-ins between phases. Holes have been found at 90% of the facilities examined so far. Do you know of other states that require this type of ELL testing?
So, interesting question, and I think that Ohio's just implemented this, and it's fascinating. So where they've been using it 90%, if that number is accurate in a question, it speaks for itself, doesn't it, Tim, on why we talk about we need to leak locate, right? So that's what I keep telling folks, that even though I do it, it's great for me because it's my business, but being my background CQA and wanting to make sure we don't miss things, such a great tool. So I'll drill into this a little bit. I was behind the scenes when Ohio, the EPA, I had folks that were on a committee that were working with the EPA over there. There was a group of us, other leak detection practitioners, that assisted with writing their rules and regulations. I think they did a nice job. I like what they're doing. I'll say this. Right now, the other states that have regulatory requirements for leak location, North Carolina, New York, New Jersey, and Wisconsin, they all require on Subtitle D landfills. The one thing that Ohio has done, they required in a regulation for leak location on the covered side. And that's after the protective cover goes down. That's where they want the testing. If you cannot do a covered method test, then they fall back to the exposed method. Again, if we're talking about being leak free, and some of the information I've given you about the covered method being designed to find the larger holes, unless you can get a lot of hydraulic head in that material, you're only going to find the large stuff. So I think what they've done is great. I still like the combination with the exposed method. They're very unique in the way they do it, but it's a good start, and I think that the numbers speak for themselves for what they're finding, and they're doing a nice job there with it.
Yeah, So, Andrew, you said New York, North Carolina, Wisconsin, and Ohio are the ones requiring it, or is there another one?
Yeah. So Wisconsin, New York, and New Jersey have had it for a while. North Carolina passed it in Senate law. It never made it into the reg, believe it or not, Tim, in Subtitle D. They've had an interpretation from a lot of the regulators in Ohio or in North Carolina that said, hey, as far as we're concerned, we need to be doing it. So a lot of the permits, I'm in South Carolina. I do a lot of work in North Carolina, South Carolina. We are seeing consistently across the board, even on old sites, that they're not being grandfathered in anymore. Any new permit or any expansion, North Carolina has been making it mandatory to have leak detection done in some form.
Perfect. Okay. And I know who asked that question, so I think you can rely on the 90%.
Great.
All right. How much standing water is required for the wet method?
Standing water for the wet methods. We talked about the wet method in our presentation. I love the wet method. The dipole, it's great. Hydraulic head, get some water forcing through that leak. You'll find it, everything. It lights up like a Christmas tree, Tim, doing that method when there's holes. So I have actually been on sites where we've had geotextile is a protective cushion above the liner. We've only had to saturate the geotextile and walk on it and get current flow through it in order to find holes. I've had other sites where we've had to start with heavy hydraulic head in order to force it through some of the smaller holes. So as a rule of thumb, I would say anywhere, if it's just you're looking at it, maybe a small little secondary retention area, maybe in a leachate holding tank, something like that, you want to check it. A couple inches, 2 to 4 inches is probably sufficient, so you can wade through it and walk through it. You want to keep your electronics out of the equipment, or the electronic parts of the equipment out of the water, and they sit about 4.5, 5 inches above it. Outside of that, I mean, it's pretty straightforward. We do modifications a lot on how we do our. We have different structures, different setups on the water method. I think I mentioned in a presentation we've done them out of a boat. We've done them in multiple ways. So, but typically, if you're looking for a minimum amount, 2 to 4 inches is sufficient. Just so you can walk in about boot level and walk through and wade it, charge the water.
Okay. Next question. Oh, slide 19. Let me go there. Slide 19. What is the reason the photo on the left is correct and the photo on the right is incorrect? And I will get there.
Slide 19.
Oops.
All right. I think right there. Yep. All right. Good question. So we went through this a little bit in the presentation, and I wanted to show this. We talked about the covered methods. You have to have perimeter isolation for these things to be accurate. And you can see the photo on the left. I can tell you how they constructed this because we did the CQA on the job. They actually put in the liner system, and then they have the black layer there that Tim's got the cursor on. That is actually the geonet that's laying on top of the geomembrane. And then there's an anchor trench to the left over there in the soil. It's anchored. And what they did is they stayed 2 feet away and they put an orange line all the way down through there. And the guy running the bulldozer knew to only put the protective cover to that line and leave a windrow. That way he had a break inside and outside. So it's nice and clean, right? The composite's clean. There's nothing there for current flow when you charge that rock to jump out across that composite and want to bleed over into the soil and lose current flow. So very clean, very nice perimeter isolation. The photo to the right, it's not that it doesn't work and it's not effective, but what they did is this is a native soil cover, very wet, somewhat silty, sticky. They covered the whole entire liner system and then had to go back through with an excavator and dig the perimeter trench back out. 2 reasons I don't like that is because you can never get those particles that are conductive out of that surface of the composite. Once it's there and it's wet and it's got soil on it, no matter how clean you get it, electric current's looking for the easiest way out. It will jump and it will try to ground itself out. The other thing is think about this. You've got a liner system there. You've covered it up. Now you're going back in with an excavator with the potential of making damage and holes to the liner system to get isolation. So you don't really want to do it this way. It can be done this way, being very cautious and cognizant of what you're doing. But ultimately, the one to the left is what you would want to do during the construction and have a plan and prepare, instead of the one to the right, where really we'll cover everything up and then we'll come back and get it set up. So both ways will work, but the one to the left is more preferable if you can go this route. Saves you a lot of time and a lot of headache.
Right. Okay. Next question. Is the copper wire for purposes of finding leaks?
Yes and no. So let's go to slide number 37.
Yep.
So when you're dealing with the multiple liner system, or as we talked in a previous question about secondary liner with the wire under it, that wire is there so you have an access point to ground. So if you think about, you've got a secondary liner system and you've got a composite or leak detection zone or whatever, witness zone is what we call it in between, and then you lay a primary liner over it and you seal it off, you can't get back in there. There's no way to get back in. So the reason we put the wires in is so we can clip onto them externally and have access. So if you look at the picture to the left, you can see that wire running out of the GCL seam. So you actually have a secondary liner that's laying on a soil subgrade. Then you've got your GCL that's laying in your leak detection, your witness zone. And then we put the wire in the seam and we daylight it out of the anchor trench. So when the primary liner goes on top of that, we can grab hold of that copper wire and have a grounding mechanism. So GCL is great in the witness zone because it's conductive. Most of the time it's hydrated to a certain point. So I see GCLs at witness zones used sometimes. They're fine. If you got a copper wire in there, they're conductive, you can get to them. The other thing I see in witness zones a lot of time is non-conductive. I see double-sided geocomposite, and when you go that route, that copper wire is there once you flood that witness zone in order to hook onto it and have something conductive to reach. So I guess to circle back around to answer your question, that wire is there, yes, to find leaks and to have some way to ground. I mean, it's all part of the system per the ASTM. It's a necessity in order to perform the test as it's specified.
Okay. Just for the listeners and watching, there's the subgrade, there's the geomembrane, there's the witness zone or geocomposite that's basically the leak detection zone. And then the GCL sitting on top of it, like you said, it's the seams folded over. And that's basically the soil part of the primary composite liner system.
That's right. And then they're going to cover that up, Tim, with the primary liner.
Exactly.
And the question is what do you ground to? Once it's sealed off, you can't get back to it. So that's why the copper wire has to be installed and put back out so we can hook onto it with our equipment and have a grounding system.
Yep, exactly.
Yep.
Okay.
Yep.
Let's see, last question from during the webinar. Can you touch on the pros/cons of installing/testing manufactured conductive geomembrane versus the method utilized within this presentation on traditional or non-conductive geomembranes?
Yeah, so good question. And I stayed away from conductive a little bit in this presentation, not necessarily on purpose, but there are some complications. So I'll say this on conductive material. I think we've demonstrated outside of ASTM 7240, which is the spark testing method on the exposed side, all these other methods will work on non-conductive geomembrane. You do not have to have a conductive geomembrane in order to perform leak detection now with the technology we have, unless you've got just a totally non-conductive system. That's where you would need a conductive liner and that's where the ASTM 7240 comes in play with the spark tester. So the pros and cons to the conductive, and I'll say this: if you have maybe a leachate lagoon on your site that you're going to continually be monitoring and doing O&M on, you're going to clean it out, muck the sludges out of it, that kind of thing, they're great because they give you an instant leak detection, sufficient conductive layer to jump right in there and check it real quick, fix what you need to fix if there's damage, and get in and get out. So in those scenarios, they're great. The downside is they're exposed to some extent. Conductive liners, they don't have the same properties as non-conductive, meaning that in order to make them conductive, you've had to ramp up the carbon black on the backside. You've taken some of the UV out. There's some things, the brittleness is a little bit different. So when you look at the properties of the material, depending on what you're trying to do as far as the design and what you're trying to accomplish, there are reasons to use conductive material. But from the leak detection side now, with the technology we have, it isn't so much a necessity anymore. But it's out there and it's available, and it is a good product. I think we may talk here later about some of the installation on the conductive, and that's where there are some complications on the install side with leak detection that we'll go over and talk about. But I guess the last thing I'll say, the conductive membrane with the properties is somewhat, you may have a shorter lifespan, and there is a little bit of an increase in cost. It's a little more expensive because they're having to dose that carbon black up in order to make it conductive.
Right. Okay. So, Andrew, I'd like to turn to the questions from the follow-up survey that went out after the webinar, both domestically and internationally. And we have 11 of those. Okay.
Wow.
Yeah. So
again, Tim, I'm trying to figure out, did I not explain very well, or is there a lot of interest? This is great because I do. This is why I love to do these presentations, is to try to educate and talk through this. So hit me.
Yeah, no, it's the interest. Almost every month we have many questions, and so it's great. It's an active audience. Number one, we are using a double liner system for a landfill and weighing options of a sand protective cover or bottom ash protective cover. Any issues with using a bottom ash material, and that's bottom ash from a coal combustion power plant situation, if we come back and use cover method for leak location? Copper wire will be installed between the two geomembranes.
So, obviously, these bottom ash, it's got to be dried before it's put in a landfill anyway. So the only problem you would have with it is it being wet, right? Other than that, I've always been a proponent of if that, we're using native soils from a site. Sometimes we use sands on sites that are actively there, especially on some of the coastal regions. But in this world that we live in on the CCR side, I don't have any reasons to believe that if you put 2 feet of this in and it's clean and it meets the screening requirements of the specification, I think it's a great reuse of the material and recycling. Why would you import something or use something when we're trying to dispose this and put it all in one system anyways? The biggest thing that you want to make sure of is it meeting the requirements, again, on the grain size and the fines, that it's not going to clog up your leachate collection system, your drainage system. You want to make sure you've got, I know that there are some complications maybe with some GCLs, some interactions with maybe some of the components with the metals and things there. Also know that some of the cloths may clog up the geotextiles, the opening. So other than that, as long as you've covered all your bases, I think it's a great use for protective cover, as long as it meets all the standards and you can prove that it's not going to gum up your system and it's going to be effective. Gets you that 2 feet, and then really, you're going with the same thing above it. So yes, and I mentioned the metals in it. electric current flows beautifully through it, through coal ash. I mean, it is highly conductive, Tim.
Right. Okay. Number 2 from the follow-up survey. Under what condition can the test be performed in a cold climate when the temperature is cold and everything is freezing up?
So we talked about this a little bit, I think, from a previous question about the ice being in holes.
Right.
So somewhat the same method. You know, if we're using an earthen cover, then the cold and frozen conditions, they just limit electrical current flow within the material. You can't get the current to move. It wants to sit and stabilize. And especially on the grounding side, you know, if you're trying to ground something and you're trying to get it to complete the loop like we showed in the demonstration, it just doesn't. It doesn't work. So so I think on slide 24, Tim, can we go to that?
Yep, I'll get there. Go ahead.
Slide 23, I'm sorry.
Okay.
All right, so the photo to the right, you can go back 23.
Yep,
Slide 23.
I got it. It's really slow. Go ahead.
Okay, understood. So you can see the photo to the right in this scenario. You know, we were showing about how to use the instrumentation once labor moves the material back. In this scenario, you can see there's snow on the ground, right? We wouldn't want to perform a leak detection test over 8 acres of protective cover in this case. This was a case where we come in, they knew they had some damage. They wanted to confirm it. We had an isolated area. They peeled it back and cleaned around it, and we're confirming the area. So just as a demonstration, this will show you that, hey, if it's frozen, if there's snow, again, it's the planning, the preparation, looking at the forecast, knowing what's coming. So ideally, you don't want to necessarily try to attempt and do a full survey in this case. But again, there are reasons why I put some of these photos in here, and some folks I think looked at those and called them out because I was hoping to get some interaction from them. So yes, good question. The cold climate, particularly anything in freezing and below in heavy snow, you don't want to do leak detection during this time. It's not on the covered side.
Okay. Number 3 from follow-up survey. Granted, there are different capital works and costs that are required for each method, but on the actual testing itself, what are the relative costs for the different testing regimes? So take out the upfront equipment, just kind of performing the testing.
So I don't have a whole lot of difference as far as square footage or let's just say acreage. And I'll give you those numbers. I know that for many, many years as I've done this, people have kind of held things close to the vest, but I like to be very transparent and upfront and honest with folks. And I'll tell you this, leak detection, if you're looking for a price range and you're looking for a ballpark, anywhere between $1,500 and $2,500 an acre to physically perform the test is a pretty good number. I've seen it, depending if you've got a lot of steep slopes and it's complicated, you may start crawling into that 3,000 an acre, that kind of thing. But pretty standard on a regular system, you know, let's just say an 8-acre landfill cell, 1,500 to 25 acres is a pretty solid number to stay in between. You know, it's kind of like I describe it as being a design engineer. If you're a design engineer and you're going to design a 1-acre cell or you're going to design a 10-acre cell, there's really not a whole lot of cost difference. What it's going to cost to do a 1-acre cell and a 10-acre cell to get it designed and permitted is about the same. So when you're trying to break that down into square footage, it's complicated, right? So, or a price per acre, it makes it complicated. So if you have a larger project, typically you would see it, if you calculated it out, it would be a lower number per acre. If you have a small 1-acre lagoon, you're probably going to see it maybe be a $7,500 job. Well, you've got to calculate in your costs of mobilization and hotels and getting someone there. and the equipment and those kind of things. But physically just performing the test, doing a survey, $1,500 to $2,500 an acre is pretty fair and pretty consistent is what we see across the board, and kind of where we try to stay. Anything that can be calculated beyond those numbers are associated with mobilization, logistics, equipment, things outside of that. But the controlled cost, $1,500 to $2,500 is a fair assessment.
Okay. Number 4, for a multiple liner system, are there any additional methods to detect leaks on the primary geomembrane if a copper wire was not installed during the initial construction?
So, so the initial construction. So I would say on this one, first of all, I'd say yes. If you have a conductive geotextile and not a, you don't necessarily, you'd like the copper wire so you have access to it, but you still got to have an access point to get in. So with conductive geotextiles, they're great solutions. There's really not additional leak detection methods to use, I would say. I mean, we've kind of went through the list in the presentation on Tuesday on the 16th of what the ASTM methods are out there. But without a copper wire, are there other conductive things or other ways to ground and use? Yes, conductive geotextiles, flooding the witness zone. I can always drop, if you flood a witness zone and I have access to the port, we can drop a copper wire into the water and bring it out and make our own ground if we have to. So there are ways around it. Again, it's experience and site specific, and there are complications. Conductive geomembrane is an option if you don't want to use a copper wire. It's one of those things to plan and prepare ahead of time, knowing kind of what you're getting into or what your options are. But copper wire is not the answer to all of it. And trust me on that. I do like these other alternatives, like a conductive geotextile, or if we're doing a double liner system, maybe looking at, if it's going to be covered and not exposed, maybe looking at a conductive layer on the top, a membrane, instead of a non-conductive.
Right.
Okay.
Okay, follow-up question to that. Would the exposed method still work to detect leaks in the primary geomembrane that is only separated by a geonet from the secondary geomembrane? In other words, so there's no soil component below the primary geomembrane.
Yes. So back to, I guess I got a little ahead of myself. So I answered the question before we got there, Tim, was, back to the conductive geotextiles in the witness zone, flooding the witness zone. Again, I did say in my presentation, I'm not a fan of flooding the witness zone. If we have other alternatives going into it, we know we can get around it and it's cost effective. And I think I described that. I don't like to flood that witness zone between secondary and primary, because I can't visibly see what's going on. And I understand the inner workings of the characteristics of geomembranes. And if you think about it, when you do a double wedge seam, is what we typically see in a landfill application or most geomembrane applications, even on a single wedge seam, if you put water or liquid in that witness zone, you are potentially, you have the capability of putting some of the seams in peel mode on the backside. And if you think about it, we're very, very adamant about the shingling following the flow of the water on the top, right? Well, then you put the witness zone in there and you're doing totally against what you wanted to do. So
right.
Now you have water going against that seam. So right now, I know a lot of designs, we're having to flood the witness zone to make it conductive. I would like to see us move toward being able to put a conductive geotextile on a net. So when we're using double-sided geocomposites, we've got a conductive layer on the surface that we're going to lay our primary on, would be nice. And then conductive geomembrane for the primary layer is an option. So yes and yes on both of those questions with the wire and with the testing.
Okay, Next one on the follow-up survey. When testing the primary, I saw snow in the images on slide 24, which is actually 23.
We're right there. Yep.
That's why I left it there. How do freezing conditions affect the testing? And I think you already answered that.
Yeah, I think we've been through that, and again, it's the flow of electric current. Good question, and it does have an effect.
Okay. Next one. When testing the primary geomembrane in an area where there is a secondary containment, only extends along a main collector trench only, and a compacted soil liner separates the primary and secondary geomembranes. Can readings on the primary geomembrane still be made as long as the grounding rod is not connected to the compacted soil liner between the primary and secondary geomembranes? That's a big question.
Woo. So when testing, I do have these in front of me. I'm just going to kind of go through it. So you've got a main collector trench, and you've got a compacted clay liner that separates the primary and secondary. So actually, in this case, Tim, in their witness zone, they put some clay in between the two layers, right?
Right.
So we've got some clay in there. So we've got something conductive. It's got some moisture in it. We've got copper wire there. And we're laying the copper wire. We're extending it out for grounding. And the answer to your question is yes. As long as the primary, the clay is over that whole primary area, yeah, we can test that, sure, and see it. A great alternative if you can get away. I have seen systems where they do use earthen separation between the primary and secondary, and that's a good alternative to that non-conductive in between your witness zone in order to have something there. So, but yes, you can.
Okay. Next question is, do you have a preference for a vendor for a conductive geomembrane? You already talked about a conductive geomembrane and some of the limitations of it, but just to answer the question, assume you were going to use it. Do you have a preferred vendor?
I do like these kind of questions, Tim. It makes me, I work with everybody, and I think across the board, as long as the material meets the specification of design, I see there's a couple specifically spelled out here on the vendors. They all have good products and will work. I don't have a preference. I really don't. A lot of the times I get on a site and the material's there. We're just there to leak locate. Are there some that have been more complicated than others? Yes. I'll say this about conductive geomembranes. When you're doing leak detection, the one critical point in conductive geomembranes is that when you roll these individual pieces out and make one big puzzle, every seam has got an exposed conductive edge, right? So if you don't terminate it with an extrusion weld and it's just there, then you've got every seam, so every 22 feet. So if you're doing a covered method, and I do the mapping system on a covered method, that seam is going to show up in a straight line on every one of these drawings, looking like it's a leak. Now, from my standpoint, I know what it is. It's not a leak. It's the seam because it wasn't terminated. I will say this, if you're going, you've got to bury this in an anchor trench and hold it in place during construction. On conductive geomembranes, you have to terminate the turn down strip that goes into the anchor trench to get the isolation. If you leave that exposed, the current wants to run out, and it wants to run out and grab. So that perimeter isolation, again, going back to our title of our presentation, planning and preparation, those are things that from a leak detection professional like me and others in the industry can keep you out of a lot of trouble if that's the way you want to go down, the product you want to use. It's worth asking those questions up front. So so I don't have a vendor preference. Again, they're all reputable and they all have great products. It's just understanding what you're getting during the installation and being prepared for it.
Okay. Next, if there is no adequate perimeter insulation or isolation in a pool with a cover, can a dipole be used?
So So I take this, Tim, let's just say we're on a protective cover landfill cell, maybe on a cap system or something, and up on the top we got a big pool, a bird bath. Is that how you read this?
Yeah, I think so.
Were they wondering if we have to expose all of the soil in order to do the test?
Yeah.
No, you don't. And the reason why is because water is far more conductive than the earthen material. So if you think about when I talk about if you can get enough hydraulic head into your material, you can see a lot of things that typically you can't when it's drier, right? It's just kind of common sense and just second nature to think about that. So we've had very good success on not having to isolate. If you think about the video we showed in the presentation on Tuesday the 16th, Tim, we actually were on a concrete Fabriform system with a 60 mil geomembrane liner under it, and we had water on top of it. And all we did is drain the pond down. We knew that the concrete was going to carry some current flow, but the water is far more conductive than the concrete. So we were able to charge the water and see holes and find holes in our geomembrane below the concrete. So that to answer your question, yes, you can do it without isolating it, as long as the water goes all the way down through. That ponded water, I'm assuming, is sitting on the liner, coming all the way up and is exposed. So yes, I see this in sump areas. So Tim, if you think about a lot of sumps, they fill them up with gravel, and then all the water runs down there, and they say, hey, before we cover this thing up, can we just have you come out and charge that and look at it? And yes, we can do it. Now in that case, you've got an isolated area, but that's a practical application where we do perform that kind of test.
Okay. Next question. A general order of magnitude of cost per acre for the different test methods would be helpful. And Andrew, you already gave 1,500.
We did that. Yep.
To 2,500 per acre, and that basically covers all the methods, right?
It does. Yeah, there's not a whole lot of fluctuation. You know, when I first started doing this, for a while, Tim, I thought between the, you know, when you're talking about the covered methods, the equipment is a little bit more tedious, right? You've got software, you've got mapping, you've got GPS, all these things. But in the bigger scheme of things, you're still performing the same tests. You're going through the same methods, so to speak, per the ASTM to accomplish the same goal. So there's not a whole lot of difference. There may be a few $100 here and there, but it's not enough for me to delineate. No, they're all about the same.
Okay, great. Last question from the follow-up survey. How do you go about cleaning sediment from a geomembrane prior to leak testing? Is a vacuum truck used or suitable for removing the mud on the geomembrane?
So let's go to slide number 8, Tim.
Okay, 8, here we go. Yep.
All right, so there you go. You got water and you got sedimentation, right, Tim? It's all washed in there. You can see it. We got a mess. So let's go to slide 9. So in slide 9, they actually came out and they power washed the surface and washed all the sediment down to the sump area and then pumped it out. You can see them using, cleaning up this last little bit of residue that's in the liquid. They're using leaf blowers, they're using push brooms to push those fines and that sediment down to the low end of the cell area or the lined area in this case. I have seen vacuum trucks used, so yes, you can, if that's something that is sufficient and readily available for you to use. You know, a lot of times on the tie-ins, I'll see folks use plastic snow shovels to clean those. You're putting plastic against plastic. We're going to leak locate it anyways. You don't want to use a spade, a steel pointed shovel necessarily against the liner surface. I do tend to lean away from using a metal flat garden shovel against the surface. I'd rather use the plastic type snow shovel. Power washing, I've seen many excavators used to clean off sediment and a long reach. Typically, you want to use a flat bar straight edge. And a lot of times I've seen you've got teeth on the excavator bucket or a flat metal piece. They actually have taken a piece of HDPE pipe and covered that, and it's nice to rake across the surface and minimize your potential to damage the liner. So there's, I'm not means and methods, but I've seen it done multiple ways and been successful to clean off liner surface.
Okay, great, Andrew. Thank you for joining us again and answering 26 questions. And more importantly, thanks to the viewers for attending the webinar and submitting the 26 excellent questions. Really great to have an active audience that's following the presentations and attending. So, Andrew, thanks again for joining us from Columbia, South Carolina. And everyone, thanks for joining us. See ya.
Thank you, Tim. Thanks, everyone.
Yep.